Hey, I made a Sudoku puzzle. Hope you like it. Okay, so let's start from the top. We're going to be importing random for inputting random digits and numpy for printing out the actual grid itself. So it's going to be a 2D grid. That means there's an x and y coordinate. So if you don't know what that means, you'll see in a second. Actually, you can just look down here. So this is a 2D grid. It means that there is arrays within a giant array. And that helps us get like an XY coordinate. So this is 0, 0, this is 1, 1, this is 2, 2. And if you're confused about why this is 0, 0, all arrays in coding start at 0. So yeah, because it's a number. Anyway, so we're going to have a couple global variables. We're going to have grid, final grid, and happens. So grid is just going to be what we're going to be working with. It's we need an initial array to mess with to find our value, and then we're going to create an instance of that grid when we have an actual working Sudoku puzzle, and we're going to put it onto this fin grid. So you're going to see when we do that in a second. And then happened is a flag for us to end our recursive loop, as well as how to control that nothing updates this fin grid again. So next we're going to define this function make Sudoku puzzle. It's going to accept something, an integer of difficulty. So that integer is just going to remove squares. So after we generate our Sudoku puzzle, which we're going to do here in a second, that's going to be filled, like it's going to be a completed puzzle, and then we're going to remove numbers to make it an actual puzzle from that point. And what we're going to be doing, how we're going to be doing that, the removal part, is we're just going to pick random spots and then set that spot to 0, and then decrement our squares to remove, and then once our square gets to 0, then our puzzle is ready and we can print it out and it's good to go. Okay, so now for the hard part. So this, I got a bit of help from a YouTube video that I'm going to post in my description below. But yeah, so I'm taking this value, 1, 2, 3, 1 to 9, and then I'm shuffling them. And that should give us a start of randomness. And then from there, I'm going to feed it into a Sudoku solver that I found online, because I couldn't get mine working. And that should spit out a solution. So initially we have to start our grid equals to 0. So this is just a one-line double for loop. So 4j, blah, 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 and we set each value to 0 within this for grid. So after that, we just update that first set of lines, and that's all we need. So for each row, it's going to have 1, 2, this shuffled value. Okay, so now the actual interesting part. We call this generate function, and we go down. So here we have grid, happen, fin grid. So if happened, return. So this is since this is a recursive algorithm, we need an endpoint. So this comes with a dual purpose. So if happened, that means we've already found the grid that we want, then we can end. Because theoretically speaking, there is thousands of ways to make a single Sudoku puzzle, like with the way I'm doing it. So we just really need the one, so we could stop once we found one. So from there, we're going x and y, and if we find a 0 value, then we want to put in if it's 1 or 1 to 9. If that value is possible, so we're going to look at that in a second. So just if it's possible to put that in, like there's no conflicts from the row, column, or the square. Then we're going to put that value in, and we're going to call it again and see how many times we can keep going. So it's going to try every possibility to fill in this puzzle. And if it doesn't work, which is the case that it gets returned, then we set it back to 0, and then we go backwards. Cool. So after you've tried all the possibilities and you've declared that this is not functioning, then we go back to where we came from. Okay. And if you do end up getting here, which means there is no value of 0 present on your grid, that means that we have a full working solution. So we save it, a copy of it, to FinGrid, which is a global variable, and then we switch happens from false to true, which would end our loop, our recursive loop. And then we now have this final value. So the last question is, what is possible? So possible check is basically just checking if there's any value that we have that will equal to what we're planning to put in. So if there's already a 1 in that row or column or square, then that's not possible. So we return false. So yeah, that's just the logic there. And this for the square. But if it is possible, then we can keep going. And yeah, finally we have what we're actually calling to begin with, and we have a user input of 1 to 2. So this is just going to be our difficulty. That difficulty is just a different number that we're going to subtract. 36, 46, 52. It could be any value, to be honest. Like, it doesn't really matter. But yeah, so then we call it with our difficulty, and then we get our end results here at the bottom. And I'm not going to solve it, but it looks right. I don't see any overlap anywhere. So yeah, you could put this down on a piece of paper or something and then make it like an actual game of it. So yeah, this is yours now. If you want anything else, just let me know, but the code will be posted below. See you around. Bye.